Welcome to my channel, Semantic Academy. Today we are going to see the discussion about phases of the compiler. We are going to see what are the different types, different phases are there. One by one we are going to see here. You see this diagram. So phases of the compiler. These are all different phases in the compiler. So every phase having specific responsibilities. Here the phases are like Lexical Analyzer. One more phase is the Syntax Analyzer, Semantic Analyzer, then Intermediate Code Generator, Machine Independent Code Optimizer, and one more is the Code Generator, then Machine Dependent Code Optimizer. So once you are passing to all these phases, you are going to get the target machine code. So finally you are expecting the machine code. To getting this particular machine code, you are going to pass all these phases one by one. And in addition to these phases, there is the requirement of the symbol table as well as the error handler. This symbol table is basically the data structure. So whatever the different variable names, constants, arrays, procedures, functions you are going to use in your program, so everything it is going to maintain in the symbol table. And we are going to discuss in detail with the example. First of all, what exactly you are passing all these phases? You are starting with a high level language or any source code. The source code you are passing to the Lexical Analyzer. So the Lexical Analyzer is dividing the source code into different tokens. So different tokens. So each and every token there should be some identity, right? Some of the identifiers you are going to represent into the symbol table. If you are divided into any token, the token is going to maintain in the symbol table. Symbol table is maintaining all the records you are using in the source code. What are the tokens? So it is you are divided based on the token values. You are going to pass these particular tokens into the syntax analyzer. So what is the role of the syntax analyzer here? The syntax analyzer is taking these tokens and it is generating one of the syntax trees. Syntax tree is basically it is a representation. What is the different tokens you are passing, based on that it is going to generate one the tree structure. In this tree structure basically you are going to validate so the given syntax is valid or not. So to check the syntax related things you are going to generate one of the syntax tree. It is a syntactically checking, right? So this syntax tree you are passing again to the semantic analyzer. The role of the semantic analyzer is semantically it is going to check. Again here also I written the syntax tree, but here the way of validation is different compared to here. The syntax tree is only syntactically, it is not worrying about that given is whatever it is generated that is meaningful or not. It is not going to check the meaningfulness. But whereas after generating from the semantic analyzer, it is going to take care about the meaningful, whatever you represented it is meaningful or not, valid or not, right? So whatever this particular syntax tree generated, you are passing into the intermediate code. Intermediate code is it is 3 address code representation. In the 3 address code, so in the single line you can represent in maximum 3 addresses. Either it may be 3 addresses or 2 addresses or 1 address. But your represented maximum is 3 addresses. That is intermediate code generator. Intermediate code generator, it is generating the sum of the intermediate representation. Whatever the intermediate representation you are getting from this intermediate code generator, simply you are passing to the code optimizer. So basically the code optimizer is optional. If you are thinking you are going to optimize the code, some of the redundancy data is there, you are going to reduce it, right? Some of the variables are repeatedly you are using, you don't want to use again, you are going to remove that, you are going to optimize. So any of the optimization thing is there. Those optimization also two types here, machine independent and machine dependent. Before this code generator phase, you are going to do the machine independent code optimization. It is you are not bothering about what type of machine you are using, what are the configuration of the machine, you are not going to worry here. You can do the optimization. But once you are passing to the code generator is generating some of the target machine code. Once it is generating the target machine code, also you are still there is a possibility of you can optimize the code. So for example, if you are using the number of registers or more, if you want to reduce it, you can reduce in this last page, machine dependent code optimizer. And many of the concepts we are going to discuss here. What are the things that comes under this machine dependent code optimizer? So basically your the backend side you are going to do this code optimizer. The last once it is target machine code is generated, still there is a possibility of the optimization, you can do it. So all these phases one by one you are going to pass, starting from the lexical analyzer, and you are going to apply the code optimizer. Finally you are going to get the target machine code. So these phases you are going to pass one by one. And what is the role of this error handler? What is the need here? So during this translation process, once the source program you are translating into the target machine code, in any of the phase there may be possibility of any type of error. So once, if it is a lexical analyzer phase, you are converting this particular character streams into the token, there is a possibility of the error. This error handler simply it is reporting. This error handler is first it is detecting, then it is reporting, right? It is going to report this lexical analyzer phase, some particular line there should be some error, it is reporting here. And there may be possibility of some syntax analyzer. If it is syntactically wrong, and if any of the case it is thinking that some error is there, just it is going to generate. Like that each and every phase, that's why this error handler is interconnected with all the phases. Is nothing but there may be chance of anywhere the error you can detect. So that's why the error handler is going to detect and it is immediately going to report it. So this symbol table and error handler and all these phases are very important. We are going to discuss in detail with example. Yeah, we discussed just now we given the different phases from starting from the lexical analyzer, syntax analyzer and semantic and intermediate code generator and code optimizer and code generator. How exactly you are going to implement all these phases? You have any source code. From the source code, how you are going to generate any the target program. So here one by one we are going to see. Actually this is the example I taken, translation of an assignment statement. In this you are going to apply this translation for entire source program, but instead of entire source program I taken only one statement from the source code. So the statement is there, position equal initial plus rate into 60. This is the given statement from the source code. It is from the source code it is a one line, right? So one definition of the statement, you are taking the one identifier variable position equal initial plus rate into 60. 60 is a constant. How you are going to translate this particular assignment statement, and finally where exactly you are going to store this particular statement, what is the representation, the storage representation we are going to see here. You are passing this particular statement from the source code, the single statement I taken here, single statement you are passing to the lexical analyzer. What is the role of the lexical analyzer? We discussed just now we discussed the lexical analyzer taking the character strings or it taking the source code and it is translating into different tokens, right? It is going to split into different tokens. Here the tokens format is, as for this example the tokens are generated here. Position I am considering it as a one token, right? Token is one of the representation, there should be some identification in the code. You are giving some identifier value also. Position in the source code this is the first variable. I am considering it as an identifier. This is the identifier. The value of the identifier should be 1 because I am starting from this is the variable I am starting. And next is the equal. As it is you have to take any of the operation, arithmetic operations or any type of operator will come. Simply you have to consider as it is within this particular bracket. And one more variable is coming here, initial. Initial is one of the identifier. So the identifier value is 2. Immediately once you define identifier 1, simply you are going to store in the symbol table in the first row. So it is occupied, the position is the identifier. The identifier value should be 1. Then second identifier is initial. The number you given is here 2. Initial also you stored in the symbol table. Then one more identifier is coming the rate. The identifier rate should be the identifier value should be 3, and operator you have to take as it is. If any of the constant is coming, it is also you have to keep as it is. No need to change. But any identifier values you have to store as it is into the symbol table. Once you represented whatever this particular statement, it is converted into the token format. After completion of this lexical analyzer phase, you are not going to see your actual code. Actual code is visible here. It is a human readable code. Position equal initial plus rate into 60. That is a human readable code. You can easily read before the lexical analyzer phase. Once you are crossing this lexical analyzer phase, the complete code is going to split it into the different tokens. The token is not human readable. So only before the lexical analyzer only you are able to read. Once you are getting the lexical analyzer phase, the output is in the tokens. That particular output you are passing to the one more phase, that is the syntax analyzer. The syntax analyzer is taking these token streams and it is going to generate the syntax tree. The syntax tree format is like this. Here how many identifiers are there? 1, 2 and 3. So every time it is taking operator as a parent. Each and every it is going to construct the tree such that it is going to check wherever the operator is there, based on the priority, it is going to check the precedence. What is the precedence of this operator? First you are going to take that particular precedence value such that you are going to complete it. Right? So your first ID1 you are storing the result. Before that you are multiplying with the 60 you are multiplication with the high precedence, and you are multiplying with the identifier 3, and the result, this part is over. These two lexemes or tokens, you can create this syntax tree. Whatever the result you are getting, you have to do the addition with the identifier 2. So you are going to do the addition here. So this complete part is, you are doing the multiplication with the identifier 3. The result you are going to add with the identifier 2. Then you are going to copy this result into the identifier 1. So this is equal symbol. Basically it is going to store. You are assigning this complete right hand side value. You are going to assign to the left hand side. This complete tree you are calling it is generated from the syntax analyzer phase. After this, so here you are going to check in the syntax analyzer. You are going to check this syntactically your code is correct or not. Whatever the tokens you generated, these generated codes. And as for the syntax tree, you are going to find out if any errors are there syntactically, your code is correct or not. Everything you are going to check in this particular syntax tree. Whatever the syntax tree generated, again you are going to pass. You are passing to the one more phase, that is the semantic analyzer phase. In the semantic analyzer phase, similarly whatever the syntax tree generated as it is, but here if any of the meaningful information you are going to check. So in this example, just I am considering all these identifiers. You are going to do the computation. Finally, you are expecting the result. The identifier 1, it is going to store the float values. Everything is in the float only, except this particular constant value. Right? Is position, initial and rate, everything is in the float format, except this 60. 60 is you taken as an integer format. Up to this syntactically it is correct, but coming to this semantic analyzer phase, but this is not correct. 60 is not correct because in this integer format you are expecting the data into the float data type. So you are going to change this particular 60. You are going to do the type conversion into float type conversion. Whatever the integer data is there, directly it is going to convert into the float data type. So this float data type, once it is converting, it is perfect. Before this conversion, semantically it is not correct. Because integer you are not going to do the computation with the other data types. Before going to do the computation, you are going to convert it. So once it is semantically checking, everything is fine. Now you are going with the intermediate code representation. Intermediate code generation, I already explained what is intermediate code generation or intermediate code representation. In intermediate code representation, in single line, so maximum you can use 3 addresses, maximum 3 addresses. Either it is 2 or 1, no problem, but more than 3 addresses you are not in a position to use, such that you are going to change your code. Here intermediate code generator, how exactly you are taking this from the semantic analyzer, how you are generating the intermediate code. Whatever the int to float conversion is there. Directly you are going to store into the temporary value t1. In the t1 you are storing, and the next step, this is you are stored in the t1. After that you are going to do the multiplication, this id and this result t1. This id and t1 you are going to do the multiplication. This result you are going to store in one more temporary variable, that is t2. This I am storing into the t2. So t2 equal id3. This is id3 and this t1 value. The result stored in the t2. Then whatever the result you are getting here in t2, you are going to do the addition with the id2. So this particular result you are going to store in t3. So t3 is storing the id2 value plus id2 plus t2 value. Whatever you represented previously in the t2, that one you are going to add with the id2. You are storing into the t3. Finally, whatever the result is there, you are going to assign into the id1. Finally, you are going to store the data into the left hand side. Left hand side, what is there? Identifier 1 is there. Identifier 1, you are going to copy the result. Whatever the result you are getting here, right hand side, you are going to copy into the left hand side. Left hand side, what is there? Identifier is 1 is there. So this is the intermediate code representation. But sometimes the intermediate code representation, there may be possibility of some redundancy of the data. If you want to try to optimize it, you can do the optimization. You have to apply any of the optimization techniques. We are going to discuss many optimization techniques in future classes. And this code optimizer, you are passing this result into the code optimizer. The code optimizer, it is going to check any of the additional storage values are there. You want to reduce those storage values. Here t1, t2, t3. 3 temporary variables you are using to store this result. One result you are storing in the t1 and one more t2 and t3. So t1, t2, t3, 3 temporary variables are required here. If you want to optimize, you can go. So code optimization part, you are not going with all these temporary values. Simply, so in this step you are converting and you are multiplying. But in the code optimizer, no need to convert in the convert and storage. Don't go. So directly you have to take this float value and you have to multiply with identifier 3. So this result directly I am storing into the one of the temporary variable t1. It means up to this portion is completed. Up to this portion is stored here. Then whatever the result you are getting, this result, whatever the result you are getting here, this is a t1. So one more step is required. One more step, what is required? Addition required. You are going to do the addition. id2 plus t1. This complete result you are going to store into the id1. Right? So here t1, t2, t3, instead of 3 temporary variables, after the code optimization, there is only one temporary variable is required. This is sufficient. Just simply optimize the code. Previously used more than one temporary variables, but because of that, a lot of memory you are going to waste, a lot of registers required once you are reaching to the code generator phase. So you don't want to waste your registers. So always you are going to focus as less as possible register you are going to store. As less as possible register you have to use, such that so you have to do the optimization techniques. Here only one temporary variable required. Whatever the result you are getting here, you are sending it to the code generator. Code generator is the last phase. In this phase you are going to get the machine code representation. In this machine code you are going to store these values into the different registers, and here you are going to use the different mnemonics. You are going to use load, multiply, add. So based on your requirement you have to use the different mnemonics here. As for this first, whatever the code optimizer two lines you are going to represent. First you are going to load id3. Identifier you are loading into the register R2. This id3, what is the id3 result you are storing into this register R2. And again to get this t1 result, so whatever the id3 is there, you are going to multiply with the 60. So id3 is already there in the R2 register, and with this register you are going to do the multiplication with the 60. The result, whatever the result after getting the multiplication, you are going to store again into the R2. This part is over. Then you are going to do the addition. For that you require one more identifier, that is the ID2. So before going to use any of the identifier, first you have to load it. So for loading purpose, you are loading R1. You are just loading this ID2, identifier 2, you are loading into the R1. Once you are loading the R1, once you are loading this ID2 into the R1, now you can use it. How you are going to use? You are going to do the addition operation. So I am using the addition. I am going to do the ID2. ID2, where it is there, ID2? ID2 is already there in R1. And the multiplication result also there in R2. Simply you are going to do the R1 and R2 registers. You are going to get the result. R1 and R2 registers, I am going to do the computation of addition. This addition result you are going to store into the R1. So finally, you are going to store the result. Final result you are going to store. For that, where you are going to store? Finally, you are expecting the result in the identifier 1. So whatever the result you are getting here, simply you are going to copy into the identifier 1, ID1. So ID1, you are going to get the final result from this particular statement. Here the position value is there. As for the source code, the position. But finally, as for this code generator, you are storing this particular position value result. You are going to store into the R1 register. So R1 from the R1 register, you can see the result. So this is the step-by-step procedure how to translate an assignment statement. In this, you have to go step by step. You have to pass this given source code into, you have to divide into tokens. This is the first step. From the tokens, you are going to pass to the syntax analyzer. The syntax analyzer is going to create one syntax tree. The syntax tree is going to generate. From the syntax, with the syntax tree, you are not in a position to check the semantically it's correct or not, but syntactically you can check it out. This syntactically, after checking if everything is fine, it is sending it to the other phase is the semantic analyzer. In the semantic analyzer, you are going to check any of the meaningful information is missing. So if it is meaningful information is missing, just you are going to translate such that should be correct. Like in this case, you are changed this 60 as an integer. If you are doing the computation in all in the float data type, so that you are translated into the float. And once you are after generating the semantic analyzer, you are translated into the intermediate code representation. In the intermediate representation, it is the 3 address code you are using. We already discussed 3 address code maximum. In the single line, you can use the 3 addresses. So you may use the 3 addresses or 2 addresses or 1 address, not an issue, but maximum 3 addresses. So that here the 3 intermediate code is generated. So this intermediate code generator, if it is possible, if you are thinking it is you are going to optimize, then you are passing it to the code optimizer phase. Code optimizer is not mandatory. If it is required as a compiler design, during that compiler design, if you are thinking if you are going to design the effective compiler, so always you have to remember if any of the additional things are there, you are going to remove it. Optimal code only required to get the better compiler, such that you are going to use this particular intermediate representation, you are going to pass into the code optimizer phase. So code optimizer result also still it is in the intermediate code representation only, like 3 address code, but only optimized way only you are doing here. Whatever the result you are getting, you are passing into the code generator phase. In the code generator is the final phase of the compiler. In this phase, it is going to store it is going to use the different registers. So in the as for our code, you are using the different mnemonics use load. Before going to use any of the identifier, first you have to load into the register, then only you are going to use for the computation purpose. You are loading ID3, you are loaded, then you are doing the multiplication. So for the result you have to store into some of the registers. Here whatever I mentioned here, the first line registers, it means for the result you are stored in the different registers, right? So load and add, and finally you are going to store the result into the ID1 you are getting the final result. This is the way of computation of the translation of the assignment statement. Thank you.